Hi everyone, I'm Sobarnika studying MCA from IT department. I'm going to explain matrices, definition, its type and its operation. Matrix is a rectangular arrangement of numbers in a rows and columns. For example, the given matrix has a two rows and three columns, so we can say its order is 2 by 3. A matrix is usually represented by capital letters like A, B, C, etc. The elements inside the matrix are written as A, I, J, where I row numbers and J column numbers. The order of matrix is equal to M into N, that is number of rows into number of columns. Example, shown a matrix has 2 rows and 3 columns. Order is equal to 2 into 3. Types of matrices: row matrix, column matrix, square matrix, diagonal matrix, identity matrix, zero matrix, scalar matrix, lower triangular matrix, upper triangular matrix, symmetric matrix, skew symmetric matrix. These are the types of matrices. A row matrix has only one row of elements. For example, here the matrix have only single row. So row defines horizontal arrangement. The column matrix has only one column of elements, so it defines vertical arrangement. For example, here this matrix have only single column. Square matrix. A square matrix has equal number of rows and columns. For example, here this matrix has 2 rows and 2 columns. A diagonal matrix is a square matrix. All the non-zero elements are only on the main diagonal. All elements outside the diagonal are zero. Main diagonal means from top left to bottom right. Here 3, 5, 8 are on the diagonal and are non-zero. Identity matrix. An identity matrix is a square matrix with a diagonal elements equal to 1 and rest equal to 0. Multiplying any matrix by identity keeps it unchanged. All its elements equal to 0. Scalar matrix. Scalar matrix is a special type of diagonal matrix where all non-zero elements are only on the main diagonal, all diagonal elements are equal and all off-diagonal elements are 0. Lower triangular matrix. A lower triangular matrix is a square matrix in which all elements above the main diagonal are 0. Elements on and below the diagonal can be any value. Main diagonal equal to from top left to bottom right. It is an example of lower triangular matrix. Upper triangular matrix. An upper triangular matrix is a square matrix in which all the elements below the main diagonal are 0. Only the elements on the diagonal and above it can be non-zero. It's an example of upper triangular matrix. Symmetric matrix. A symmetric matrix is a square matrix that is equal to its transpose. A matrix A is equal to Aij of order n into n is a symmetric if A equal to A transpose or Aij equal to Aj for all I, j. For example, here A is equal to A transpose. The matrix is a square and matches its transpose, so it is symmetric matrix. So some key points are only square matrices can be symmetric. All elements mirror across the main diagonal. Main diagonal elements can be any value. A12 is equal to A21 and A13 is equal to A31 and A23 is equal to A32. Skew symmetric. A skew symmetric matrix, also called anti-symmetric matrix, is a square matrix whose transpose is equal to its negative. A matrix A is equal to Aij of order n into n is a skew symmetric if A transpose equal to minus A or Aij equal to minus Aj for all I, j. All diagonal elements must be 0 because Aii is equal to minus Aii tends to Aii is equal to 0. Here A12 is equal to minus A21 and minus A13 is equal to A31. All diagonal elements are 0. Some key points. It must be a square matrix. Diagonal elements are always 0. Elements mirror across the diagonal with the opposite signs. Matrix operations. Matrix operations are the various ways we can manipulate matrices mathematically. Some matrix operations are addition, subtraction, scalar multiplication, determinant, inverse, transpose, matrix multiplications. These are the matrix operations. Matrix addition. Matrix addition is the operation of adding two matrices of the same order by adding their corresponding elements. Both matrices have the same number of rows and columns. If A and B are of order m into n, then A plus B also of order m into n. C is equal to A plus B, where Cij is equal to Aij plus Bij. For example, here there are two matrices, so it add each corresponding elements. Some key points: only matrices of the same size can be added. Addition is commutative, that is A plus B is equal to B plus A. Matrix subtraction. A matrix subtraction is the operation of subtracting one matrix from another by subtracting their corresponding elements. Both matrices must have the same order, that means same number of rows and columns. If A and B are order of m into n, then A minus B also of order m into n. C is equal to A minus B, where Cij is equal to Aij minus Bij. Some key points: only matrices of the same size can be subtracted. Subtraction is not commutative, that is A minus B is not equal to B minus A. Subtraction is associative with the negative. A minus B plus C is equal to A minus B minus C. Here we have two matrices that subtracting one matrix from another by subtracting their corresponding elements. Scalar multiplication. Scalar multiplication is the operation of multiplying every element of matrix by a scalar, that is a number. If A equal to Aij is a matrix and K is a scalar, that is we represent Ka, that is equal to K into Aij. So here we have a matrix 1, 2. So that multiplying with the scalar 3. So the result matrix is 3, 6. Determinant. Determinant is a scalar value associated with a square matrix that provides important information about the matrices, such as whether it is invertible. Determinant is defined only for square matrices. If determinant of A not equal to 0, the matrix is invertible. If determinant of A is equal to 0, the matrix is singular. So here we have a 2 by 2 matrix. So determinant of 2 by 2 matrix is AD minus BC. So we have a matrix with the elements 1, 2, 3, 4. Then the determinant of this matrix is minus 2. In the case of 3 by 3 matrix, we have a matrix of elements A, B, C, D, E, F, G, H, I. So determinant of A is equal to A of E, I, F, H minus B of D, I minus F, G plus C, D, H minus E, G. First we assigning values like positive, negative, positive. Then here we taking 1 into determinant of this matrix 0, 3, 5, 4. Then next we choosing minus 2 into this matrix plus 3 into this particular matrix determinant of this matrix. So finally we get the result 25. Inverse of a matrix. Here we have a 2 by 2 matrix. So the inverse can be found quickly using the simple method. Swap the elements of the main diagonal A and D and just apply negative. Transpose. The transpose of a matrix is obtained by flipping its rows into columns or columns into rows. So here we have a matrix with elements 1, 2, 3, 4. Then the transpose of this matrix is 1, 3, 2, 4. Matrix multiplication. Matrix multiplication is the process of multiplying two matrices to get a new matrix. Condition: if A is of size of m into n, B is size of n into p, the number of columns of A must equal number of rows of B. The resulting matrix C equal to AB will have m into p. So here an example of matrix multiplication. We have a matrix of elements 1, 2, 3, 4 and we have another matrix of elements 5, 6, 7, 8. So multiplying these two matrices to get 1 into 5 plus 2 into 7. This is the first element. And 1 into 6 plus 2 into 8 is the second element. And 3 into 5 plus 4 into 7 is the third element. And 3 into 6 plus 4 into 8 is the fourth element. So we get the new matrix.